Okay, let's unpack this. Imagine you're holding a tiny pebble,
Right.
like no bigger than a jelly bean, just sitting right there in the palm of your hand.
Sounds pretty insignificant.
Yeah, exactly. But now imagine someone telling you that this one tiny little stone is worth more than, say, a whole fleet of private jets.
It's wild to even try to wrap your head around that.
Right. I mean, $35 million to be exact, because usually, when you and I look at a rock, even a really, really pretty one, our brains just sort of categorize it as, well, a piece of the earth.
Yeah, I mean, we fundamentally expect value to take up space, like a skyscraper, or maybe something that actively produces something like a tech company or a manufacturing plant.
Exactly. But today, our mission for this deep dive is to explore the world of elite colored gemstones, specifically rubies. And in this world, that normal logic just completely breaks down.
It really does. It's a landscape where insane value is concentrated into this just microscopic space.
It is. We've got a huge stack of sources today. We're pulling from historical lore from the GIA, some really intense 2026 financial market forecasts, high-tech gemological lab data from SF, and recent auction records from Sotheby's.
Yeah, and when you look at all that data together, it paints this picture of an ecosystem where geology just sort of collides with absolute human obsession.
Totally. So before we can even begin to understand why, tech billionaires and these huge institutional investors are paying $35 million for a single red stone, we need to understand what exactly makes a ruby a ruby.
Right, because structurally speaking, the whole foundation of this stone is essentially invisible.
Yeah, let's start there. The base material, right?
Yeah, so the base material of a ruby is actually a mineral called corundum,
Okay.
which is just crystalline aluminum oxide.
Mm.
And pure corundum, in its completely natural state, is completely colorless.
Like glass.
Exactly, it looks just like clear glass. But it's also exceptionally tough. Like, it sits at a 9 on the Mohs scale of mineral hardness.
Which means only a diamond, which is a perfect 10, can actually scratch it.
Exactly right.
So we start with this super tough, perfectly clear crystal, and then we basically get a happy geological accident.
That's a good way to put it.
Like, imagine you have a glass of perfectly clear water, and you just drop in a single intense drop of red food coloring.
Right.
In the case of the ruby, that food coloring is a trace element called chromium.
Yes.
So deep in the Earth's crust, this tiny pinch of chromium just sneaks into the crystal lattice while it's forming, replaces a few aluminum atoms, and totally distorts the internal structure.
And what's fascinating here is how that physical distortion actually changes the behavior of light.
Okay, how so?
Well, the chromium doesn't just sit there acting like a static die. It interacts dynamically with photons.
Oh, wow.
Yeah, so those chromium atoms inside the lattice absorb light from, like, the ultraviolet and yellow-green spectrums. They take in all that energy, and then they actively emit it back out as red fluorescent light.
Wait, really? So it's not just reflecting the red light around it?
No, it's actually glowing from the inside out. It is generating its own red light.
That is mind-blowing.
Yeah, so when jewelers talk about a ruby's inner fire, they aren't just being poetic. It's a literal, measurable, physical phenomenon.
And it's a phenomenon that's so powerful it actually changed modern technology, right?
Oh, absolutely.
Like, back in 1960, this physicist, Theodore Maiman, realized that if you pump enough energy into a synthetic ruby crystal, those chromium atoms act like a trap.
Right, they hold it.
Yeah, they hold on to the energy and then release it all at once in this highly concentrated, coherent beam. He literally used a ruby to power the world's first working optical laser.
Emitting at exactly 694 nanometers.
Exactly. So the tech powering, everything from supermarket barcode scanners to laser eye surgery, it essentially started with the engine of a ruby ring.
It's incredible. But, long before scientists were in labs measuring nanometers, ancient cultures just intuitively recognized that energy.
Yeah, the history here is so intense.
It is. If we look at the historical lore from the Gemological Institute of America, the GIA, the ancient Sanskrit word for ruby is Ratnaraj.
Ratnaraj.
Yeah, which translates directly to king of precious stones.
Because they didn't just think it was like a pretty rock. They legitimately believed an inextinguishable flame burned inside it.
Right, a literal fire.
Yeah, a fire so intense they thought it could shine right through thick clothing or even boil a pot of water if you just drop the stone inside.
It really speaks to the visceral reaction humans have to that specific glowing blood red color. It triggers something super primal in us about, life and passion and survival.
Definitely. And the ancient Burmese warriors, they took this to an absolute extreme.
Oh, they absolutely did. They believed rubies granted physical invincibility in battle.
But the crazy part is, you couldn't just wear the ruby on a necklace, right?
No, that wasn't enough.
To get that invincibility, the lore says they would literally slice open their own flesh
Ugh.
and insert the rubies directly into their bodies, like sewing them up so the stone actually became part of their physical anatomy.
The psychology there is just incredible.
Yeah.
They were literally merging themselves with the Earth's toughest, most vibrant anomaly just to absorb its power.
Okay, so the science of the fluorescence is amazing, and the ancient warrior history is wild. But let me push back a bit and challenge the core logic of the modern market here.
Sure, go for it.
If every ruby is essentially just corundum with a drop of chromium, why does the financial market care so much about which ruby you buy?
Ah, right.
I mean, if they are chemically doing the exact same thing, why is one ruby at the mall worth $50 and a ruby at Sotheby's worth $35 million? What
Right.
makes the ultimate ruby?
Well, it all hinges on this. It is, yeah. It comes from the ancient Burmese word kotwe. But today, laboratories don't just look at a stone and guess if it looks like pigeon blood. Organizations like GRS, the Gem Research Swiss Lab, they have these rigid mathematical metrics.
Right, they use science now.
Exactly. To
Yeah.
earn that pigeon blood designation, a ruby has to fall into their vivid red category.
Which means it has to hit very specific benchmarks, right? Like the sources mentioned, it needs at least a 51% red saturation.
Yep, 51% saturation, but combined with a very subtle blue undertone.
A blue undertone, wouldn't that make it purple?
You'd think so, but that hint of blue actually pushes the red to appear deeper and more vibrant. It keeps it from washing out into a pinkish color.
Oh, interesting.
And crucially, it must exhibit that intense natural chromium fluorescence we just talked about.
The inner glow.
Exactly. When you combine all those factors and you don't have any structural flaws blocking the light, well, you get a stone that represents less than 1% of all rubies ever mined.
Wow. Less than 1%. And historically, the absolute pinnacle of those stones, the ones that literally defined the pigeon blood standard, they came from one really specific geological pocket, right?
Yes, the Mogok region in Myanmar.
Which used to be Burma.
Right. And for centuries, the mantra for collectors was literally just Burma or nothing.
Because the geological conditions in Mogok were just a perfect storm. Like the marble-hosted deposits there naturally favored that high fluorescence.
Exactly.
And the ultimate example of this from the auction records is the Sunrise Ruby,
Oh, yeah. What a stone.
a 25.59 carat Burmese pigeon blood ruby. It sold for $31 million.
Which is well over $1 million per carat.
Insane, but this is where the 2026 data gets really disruptive, doesn't it? Because you can't just rely on Burma or nothing anymore.
No, you really cannot. If we connect this to the bigger picture, the entire landscape of origin has shifted radically in 2026.
Because of supply, right?
Supply and politics.
Yeah.
The Mogok mines are just severely depleted after centuries of extraction. And when you combine that geological scarcity with the political instability.
Right, the international trade sanctions currently affecting Myanmar.
Exactly. The supply pipeline of new investment-grade Burmese rubies has effectively flatlined.
So the market needed a new superstar, and they actually found it in East Africa.
It did.
Specifically, the Montepuez mine in Mozambique. I mean, they really only started discovering massive ruby deposits there around 2009.
Yeah, it's very recent history for the gem world.
But it completely upended the traditional hierarchy.
It did, but, the initial skepticism from traditionalists was huge.
I bet. It's not Burma.
Exactly. But the physical proof became undeniable. If you look at the Estrela de Fura, a staggering 52.22 carat pigeon blood ruby mined in Mozambique, it absolutely shattered records.
That's the one that sold for $35 million.
Yes. Proving to the world that African deposits could produce stones that rival and sometimes even exceed the finest historical Burmese stones.
And looking at the 2026 financial forecasts, there's a totally different driving force behind this shift to Mozambique, the ESG factor.
Environmental, social, and governance priorities.
Yeah, the millennial and Gen Z investors who are taking over the hard asset market, they don't just want a pretty stone anymore. They demand what the industry's calling clean rubies.
Right. The modern wealth accumulator wants the story of the stone to be as flawless as the gem itself. They demand ethical traceability.
Which is hard to guarantee.
It is, but Mozambique and Madagascar mining operations are leaning heavily into blockchain integration.
Ah.
They're providing a cryptographically secure, verifiable mine-to-market digital trail. And because of this transparency, ethically sourced African rupees are frequently commanding more interest from new buyers than the older, sanctioned Burmese stones.
Because those carry historical baggage.
Exactly.
Okay, so we've established that a genuine untreated pigeon blood ruby is incredibly rare, less than 1% of the market, and worth millions. But human ingenuity being what it
Oh
is.
boy, here we go.
Right. Whenever something is that rare, someone is going to try to fake it or at least fix the 99% that didn't naturally make the cut.
That is the inevitable reality of any high-stakes commodity.
Mm.
Because natural perfection is such a statistical anomaly, human intervention is just the industry norm.
Right.
It is estimated that 95% of all natural rubies on the market today undergo heat treatment.
95%.
Yeah, they are placed in specialized ovens and literally cooked at temperatures up to 1,700 degrees Celsius.
1,700 degrees. I mean, that's basically the temperature of volcanic magma. What does baking a rock at that temperature actually achieve?
It dissolves internal imperfections. You see, natural rubies often form with these tiny intersecting needles of a mineral called rutile trapped inside them.
Okay.
In the trade, this is called silk. Heating the stone to that extreme temperature physically melts those rutile needles into the surrounding crystal lattice.
Wow, it just melts it away.
Exactly. It clears
Yeah.
up the cloudiness and can dramatically intensify the red color.
But let me push back on how the market values this. If 95% of the market accepts heat treatment and it physically improves the stone by just melting its own internal silk to make a better color, why is an unheated stone worth so much more?
It's a fair question.
I mean, it's the exact same rock, exact same chemical makeup, just cooked by human hands instead of geothermal activity over millions of years. Why does the origin of the heat matter to investors?
Well, because in the highest tiers of wealth, value is derived entirely from the sheer improbability of nature doing it alone.
Oh, I see.
An unheated ruby with perfect clarity and color represents a geological lottery ticket. Human heat treatment democratizes beauty.
Which makes common.
Exactly. The ultra-wealthy are paying a premium to own the 1 in a billion anomaly that didn't need our help to be perfect.
Okay, that makes sense. So heat treatment is accepted because it's just manipulating what's already there. But then we get into the treatments that cross the line into outright deception.
Yes.
Like lead glass filling. Let me try to visualize this.
Mhm.
Imagine you have an old, crumbling road full of massive, jagged potholes.
Okay, a terrible road.
Right, basically unusable. Now, imagine filling all those potholes with clear, shiny ice.
Ooh, I like this analogy.
Right. For a second, the road looks perfectly smooth and beautifully paved, but the moment you drive a heavy truck on it or the weather gets warm, it completely shatters.
Yep.
That's essentially what lead glass filling is doing to a low-grade rupee, right?
That is a highly accurate way to look at it. They take this highly fractured, opaque corundum that would normally just be ground up for, like, industrial sandpaper.
Literal sandpaper material.
Yeah, and they submerge it in molten lead-rich glass. The glass seeps into all those fractures, and because it has a high refractive index, it tricks the eye. It dramatically improves the transparency, making a worthless rock look like a high-end gemstone.
But wait, if it's filled with glass, it's not a Mohs 9 anymore, right?
Yeah.
It fundamentally destroys the structural integrity.
Far from a 9. The overall hardness drops significantly. The stone becomes a composite material, behaving more like a 6 on the Mohs scale.
Oh, wow, so it's really fragile.
Incredibly fragile. In fact, if you wear a glass-filled ruby on your finger, everyday household chemicals become an existential threat.
You're kidding. Like what?
Like even a mild acid like lemon juice squeezed over a salad.
Seriously?
Yes. It can seep in, etch, or literally melt the high lead glass right out of the fractures, leaving you with just a cloudy, shattered rock.
That is wild. So that covers the bakes and fakes for natural stones. But what about stones that never even touched the Earth's crust at all? The true synthetics.
Right, the lab-grown ones. Artificial rubies aren't actually a new concept. They've been around since the late 1800s.
Right.
But the modern methods are industrial marvels. Take the Verneuil flame fusion process.
Flame fusion. Sounds intense.
It is. They take powdered aluminum oxide and chromium and drop it through a superheated blowtorch.
Wow.
Yeah, and as the powder melts, it drips down and slowly crystallizes, building a ruby layer by layer, almost like a stalagmite forming in a cave.
And then there's the Czochralski pulling method, which sounds even crazier.
The Czochralski process is fascinating. They take a massive metallic crucible, usually made of platinum or iridium, and heat a chemical soup of corundum and chromium until it's completely molten.
Like a glowing soup.
Exactly. Then they take a tiny, perfect seed crystal of ruby, lower it just until it touches the surface of the molten liquid, and then slowly, meticulously pull it upward while spinning it.
And it just grows.
Yes. As it pulls up, the liquid cools and crystallizes onto the seed, growing a massive, flawless, cylindrical ruby over a period of weeks.
And these are chemically, optically, and physically identical to a natural ruby, but the economics are staggering.
Oh, completely.
Like, a synthetic ruby produced this way might cost between, what, $1 and $5 a carat to manufacture?
Oh, right, yeah.
Compared to a high-quality, unheated natural ruby that starts in the thousands and quickly scales into the millions.
It's a huge gap.
With a price gap that vast, how do the world's top laboratories like SSF, the Swiss Gemological Institute, actually catch a perfect synthetic? I mean, if it's literally the exact same material, what gives it away?
Well, they have to deploy an arsenal of highly advanced scientific equipment. They always start with optical microscopy to look for structural clues.
Okay.
In natural stone, you'll see natural fingerprint inclusions, or that intact rutile silk we talked about. But in a synthetic stone formed by flame fusion, the rapid cooling process often leaves behind curved striae.
Curved striae.
They're microscopic curved growth lines. Or you might see elongated gas bubbles trapped inside the crystal.
But wait, what if they used the Czochralski pulling method? What if it was grown so slowly and so perfectly that there are no bubbles, no curved lines, and it looks completely flawless under a microscope?
If the visual inspection is inconclusive, they bring in the heavy artillery.
Oh.
First, Raman spectroscopy.
Which is lasers.
Yep, they fire a laser directly into the stone. They measure how the light scatters when it hits internal microscopic crystals, which lets them identify the exact minerals trapped inside. But the ultimate test is a technique called LAICP-TOF mass spectrometry.
Okay, LAICP-TO. We have to decode that acronym because it sounds like something straight out of a sci-fi movie. What exactly is happening to the ruby in this machine?
Okay, so LA stands for laser ablation. They fire an incredibly precise, high-powered laser at a microscopic hidden area of the ruby, physically vaporizing a tiny speck of the stone.
Oh, vaporizing it?
And the ICP.
ICP is inductively coupled plasma. They take that vaporized gem dust and run it through a plasma field that is literally hotter than the surface of the sun.
That's insane.
It instantly turns the atoms into charged ions.
So they've zapped a microscopic crater into the ruby, turned the dust into superheated plasma ions, and then what? What does the TOF do?
TOF stands for time of flight. They shoot those charged ions down a vacuum tube and precisely measure how long it takes them to reach the detector.
Oh, because different elements have different weights.
Exactly. Heavier elements fly slightly slower than lighter ones. So by timing the flight of millions of ions, the computer can map the exact chemical makeup of that ruby down to parts per billion. Parts per billion. So what is the smoking gun they're actually looking for in that plasma data?
They're looking for trace elements that act as a geological fingerprint. A natural ruby will contain extremely specific trace amounts of elements native to the Earth's crust where it formed, like vanadium or iron.
Okay.
But a synthetic ruby grown in a lab might contain microscopic traces of platinum or molybdenum.
Wait, where does the platinum come from if the recipe is just aluminum and chromium?
It actually flakes off the metal crucibles used to hold the molten liquid during that Czochralski process.
Yo!
Yeah, so if the mass spectrometer detects even a few parts per billion of crucible metals in the chemical makeup, it is a dead giveaway that the stone was grown in a factory, not the Earth.
This level of intense atomic scrutiny brings us directly into the reality of the 2026 financial market. We are literally talking about an asset class where investors need to vaporize pieces of their investment with plasma just to verify what they bought.
And this raises an important question, doesn't it? If we connect this to the bigger picture of the hard asset economy, the stakes are simply too high for guesswork. How do investors actually navigate this?
Especially considering the massive premium on unheated rubies right now. The data shows they command 150 to 300% premium over heated stones. A 3-carat unheated investment ruby can easily fetch $150,000 or more per carat.
It's astronomical. And to navigate that, investors use a protocol that 2026 market analysts call agentic ingestion.
Let's break that down because it sounds highly automated. What does it actually mean for a buyer who's about to wire $500,000?
It means that the valuation of a ruby is no longer determined by someone just looking through a magnifying loupe. The value is now inherently digital.
Right.
Institutional buyers utilize AI agents to ingest, cross-reference, and verify massive disparate data sets in milliseconds.
Like what kind of data?
Historical auction prices, real-time geological depletion rates of specific mines, and most importantly, cryptographically secure lab reports. The market relies entirely on verifiable, immutable data from the big three labs, the GIA, SSCF, or GRS.
So the paper is almost as important as the rock itself.
If your digital footprint doesn't reconcile perfectly, the physical stone is virtually unsellable at the top tier. But if you have that secure provenance and the laboratory certificate explicitly states pigeon blood, that single phrase triggers the algorithm to add an instant 40% premium to the baseline valuation.
Wow. Okay, I have to ask the obvious question then.
Sure.
If the financial entry point is that astronomical and the verification requires AI and sun-hot plasma and a single microscopic flake of platinum can crash your investment to zero, why not just buy a different red gemstone?
Yeah, I get that.
Why subject your portfolio to the stress of the ruby market?
Well, that is exactly the question driving a massive pivot among savvy buyers toward red spinel. Historically, red spinel was known in the trade as the ballast ruby. It is so visually similar to a true ruby that for centuries no one even knew the difference.
Really?
Yeah. Some of those famous rubies in history, including pieces of the British crown jewels, are actually spinels.
Oh, right. The famous Black Prince's ruby set in the imperial state crown. It's an imposter. It's a massive red spinel.
Exactly right. And in the 2026 market, spinel has become the smart buy. A top-tier, vivid red spinel currently trades between $8,000 and $22,000 a carat.
Which is a fraction of the cost of a comparable ruby.
Exactly. You get the scale, you get the deep red color, and you completely skip the intense anxiety of the ruby market.
Nah.
But from an investment standpoint, there is a fundamental catch.
What's the trade-off? Because there's always a trade-off.
Two things, actually. First, durability. Spinel sits at an 8 on the Mohs scale, while ruby's a 9. It's tough, but it's not corundum tough.
Okay, and the second thing?
Second, and more importantly, spinel is singly refractive and lacks that specific chromium-driven interaction we discussed earlier. It does not possess the intense internal fluorescence of a ruby.
Ah, so it's a beautiful, rich red, but it doesn't generate its own light. It doesn't glow.
Right. The nuance there is critical. Spinel is currently the aesthetic buy for collectors who want visual impact without the massive premium. But ruby remains the prestige financial buy. The ruby's multi-million-dollar valuation is insulated by its sheer geological impossibility.
So what does this all mean for you listening right now? The next time you look at a piece of ruby jewelry in a store window, or maybe inherit a red stone set in a vintage ring, you aren't just looking at a pretty red rock.
Not at all.
You are looking at a geological anomaly, a microscopic lattice distorted by chromium to capture light and literally fire it back at you. You're looking at a piece of ancient lore, an artifact that warriors willingly carved into their flesh in the pursuit of immortality.
It really is wild when you put it like that.
And you're looking at a marvel of high-tech laboratory detection that requires lasers, plasma, and time-of-flight measurements just to verify. And in the 2026 economy, you're looking at a highly guarded, cryptographically secured financial asset that routinely outpaces the traditional stock market.
It is the ultimate convergence of natural chaos, historical mythology, and hyper-modern data economics.
But here's where it gets really interesting.
Okay.
Think about the trajectory we're on right now. As our technology for creating synthetic rubies via processes like Czochralski pulling becomes so flawlessly perfect, meaning we eventually figure out how to eliminate the gas bubbles, smooth out the curved lines, and remove every last stray atom of platinum from the crucible.
Which is inevitable.
Right. What happens when even the LA ICP-TOF mass spectrometer struggles to find a single difference between the lab and the Earth? Will the future concept of rarity become completely detached from the physical stone itself?
That's a great point.
Decades from now, will a ruby's true multi-million-dollar value exist purely as a digital blockchain receipt proving its origin, while the physical pebble in your hand is just, a pretty afterthought?
It's a profound thought. When human engineering makes the replica atomically indistinguishable from nature, the only differentiating factor left is the story.
And the data. It definitely makes you look at that tiny jelly bean-sized pebble in a whole new light. Well, thank you for joining us on this deep dive into the sources. Keep questioning the world around you, and we'll see you next time.